Alright, so this is an intro video for chapter 11. We're finishing our organic unit essentially. We have these last few things to add in: aldehydes, ketones, carboxylic acids, esters, amides. And just so you guys know, you've learned a lot of stuff already in this organic, and I've been really impressed. You guys are good with this stuff, right? But there's just one more chapter here, and it is a tough one. So just stick with it. Make sure you're trying, right? It's going to be tough. Make sure you're asking questions when you have to ask questions. But basically, this entire chapter deals with the carbonyl group. So we have one new class, and actually we've talked about a couple of these things before. But when I say carbonyl group, I mean that I have a carbon that's double bonded to an oxygen, right? Now, in your notes on the slides, it has this generic form where you have an R and a Z that are also attached to carbon. And that's just because aldehydes, ketones, carboxylic acids, esters, amides are all completely different things. Right? And you've already recognized or learned to recognize the difference between, say, an aldehyde like this and a ketone like that. So remember, an aldehyde was when that double bond was on the end of a chain. A ketone was when it was in the middle of the chain. But essentially, right, for an aldehyde, Z is a hydrogen, right? I have a hydrogen attached here. I just don't normally draw that, right? Whereas for a ketone, both of the attached things are alkyl groups, right? Groups of carbons. So there's one methyl attached to each side of my carbonyl carbon here, right? And it could be a longer chain, obviously. But you guys already know how to recognize the difference between an aldehyde and a ketone, so don't make that any more difficult than it already was. So that R and Z is there to kind of define things, but if you can recognize the difference, you should be fine anyway. So again, you already knew that this was an aldehyde. You already knew that this was a ketone. We just got to add in a few more options, right? Because we're also going to have a carboxylic acid in this chapter. So if any given carbon has more than one oxygen attached to it, it's a new thing, a whole new thing, right? With specific properties, right? You can also have an ester, right? And an ester looks similar, except for instead of a hydrogen being attached to this oxygen, I have at least one more carbon, right? So that's an ester. An amide, same kind of look to start, but I'm attached to a nitrogen. And again, an amide, right, amines that we talked about before, I actually may or may not have another carbon attached here. I could have two different carbons attached there, and it'd still be an amide, right? And if there was a third one, it would just be a quaternary example of an amide. So, again, you should be able to see that there is technically a carbonyl group in every one of these examples. There's a carbon that's attached to an oxygen in all, but the subtle difference is what else is attached to that carbon. That's what makes it all these different things. So again, aldehydes and ketones, we're already good with those. We just need to add in some carboxylic acids, esters, amides. Plus, we need to know how to name aldehydes and ketones because we didn't know how to do that before. You can't just get away with telling me that it's an aldehyde on this next test. What is that specific aldehyde's name? This specific aldehyde that I drew is actually a butanal, right? I'm going to talk about how to name these things in upcoming notes. So again, that Al ending tells me it's an aldehyde. But means 4, right? That's actually pretty simple. Whereas this is going to be called over here a propanone. And understanding ONE ending, ketone, ONE, right? AL beginning, AL ending, right? They're really not that hard to distinguish. Sometimes you need numbers, other times you don't, right? In neither one of these cases do I need a number. But I rarely need a number in an aldehyde, or I never need a number because it's always going to be a 1. That was the whole point of it being on the end of a chain. Whereas for this propanone, it's technically a 2-propanone, but I don't need the 2 because I don't need to tell you where that is because that's the only place it could have been. Whereas if I had a longer chain of carbons, I could put the double bond to oxygen in different places. I could put it on the 3 carbon, but I could also put it on the 4 carbon, and those would be different. So a 3 in this case, what is that overall? 5, 6, 7. A 3 heptanone is different than a 4 heptanone. So we'll work on those things as we go. We'll also learn how to name carboxylic acids, esters, amides. But otherwise, this first section and the next few videos are all just going to be aldehyde examples. So again, an aldehyde, you have your carbonyl group, you have some R group, and that Z group is always a hydrogen, right? So that was the difference. So if it's always on the end, if that double bond to oxygen is on the end, right, you should be able to recognize an aldehyde pretty easily. Now that R group can also be a hydrogen, it turns out. The simplest aldehyde is actually a 1 carbon chain, right? This would either be called a methanal, or more frequently, it's called formaldehyde. Excuse me. And you've heard of that before. Formaldehyde is that stuff they use to embalm dead tissues. So again, we've referred to that before because it's a reduced form of sugar, right? It is actually technically a carbohydrate. There's 1 water per carbon. About other aldehydes that you may or may not be familiar with, right? And this is kind of a complicated one. This is an aldehyde. It's also a aromatic aldehyde, and it also has some extra crap on it. There's a hydroxyl group here, so it's also an alcohol. There's also an ether kind of look down here. There's carbon, oxygen, carbon, and there's that benzene ring, right? But up here specifically, right, because there's a carbon double bonded to an oxygen, and there'd also be a hydrogen here. This up here makes this an aldehyde, and aldehyde is going to get priority over all of those things that we named previously. So this would never be called a phenyl, even though it has the hydroxyl group to make it one of those things. It would never be called that because it's an aldehyde first. But this is also too complicated for us to name. What you would know it as is a substance called vanillin, and it's actually that molecule that you smell when you smell vanilla, right? This literal molecule is what you actually sense to smell that certain scent that I'm assuming we're all familiar with. So we've all smelled vanilla. That's the molecule. It's an aldehyde. Otherwise, aldehydes are in sugars, as you can see in your notes. Again, technically, formaldehyde is a sugar. It's a carbohydrate. It's also condensed sometimes. It depends on what we're looking at. Again, remember if I had like that butanol from the last slide, if I had this, I might condense that to look a little bit different. So that if we did that R kind of look, let's say we did it in an expanded way, it's CH3, CH2, CH2, that last carbon, they'd write CHO, and that can represent an aldehyde, right? So just learn to recognize that. Depends on the format. I won't use that very frequently, but you would have to know that in other classes possibly. All right, so the next couple of videos are all about naming, reactions, everything else for aldehydes. We'll get to ketones and everything else later, but we're just going to start with aldehydes and work from there.